We are now ready to learn about the regression line. A linear regression line is a straight line, and it passes through the center of all of the y-scores at each x on the scatter plot. So here's how this works. We take our raw data, which are pairs of x and y scores. We plot them on an x and y axis. We go over x and up y, put a dot, that becomes a data point. Having put all of the data points into our scatter plot, we can then draw a straight line that best represents the relationship between x and y through those data points. Now, we could just do that by hand, or we could do it mathematically. And mathematically is going to be the better way to go. In order to use the math, we're going to need some formulas. And once we have those formulas, we're going to be able to calculate that line. And what we're going to find is that once we have that line, we could measure the distance of every data point to that line, and we would find that the distances of the data points above the line would balance out the distances of the data points below the line. In other words, that line is going to work a lot like an average or a mean. The distances above balance out the distances below. So if we were to look at a simplified form of this, what we would see is that the distance of any point to the line could be added up and balanced against the distances of those on the other side of the line. So in this case, we have the size of the snake and the anxiety produced, and we see a fairly strong positive relationship for fear of snakes with our linear regression line. That linear regression line is like a mean because it passes on the average through the middle of the data points. And then what we're going to want to do is use that regression line for prediction. You know that everything in the universe can be broken down to mathematics, and we can describe the world of physics with mathematical formulas. Well, in this case, we're going to start with a very simple mathematical formula, and it is the equation for a straight line. Most likely at some point in your life, you've used a program, maybe it was PowerPoint, maybe it was just Microsoft Word, but you've used a program on your computer in which you could draw a line. What you probably didn't know was that behind the scenes, your computer is not drawing a line, it's creating a mathematical formula. And this is the formula that your computer is using to show you a straight line. The formula is y hat equals a plus bx. So let's break that down. Y hat. You will sometimes see this as y prime with a little something that looks like an apostrophe after the y, but more commonly y hat. It has that little caret over the top of the y. That caret, that y hat, is the predicted value for y. So it is our final predicted value. That's what we're trying to get to. We're going to predict a y value based upon a, b, and x, where a is a constant. And the constant represents the value, the predicted value for y, when the x value plugged into the equation is 0. So notice it's a plus bx. If we plug in an x value of 0, what does that mean for the equation? It means it's going to cancel out the b. So y prime would equal a. So a is a constant. It is a baseline. To that, we're going to add the slope of the line. The slope, let's say the line is not horizontal, the line is not vertical, it's somewhere in between. It's on some kind of an angle. That's what we mean by slope. And the x value, that's a raw score that we use for prediction. What's going to happen is you're going to calculate a, you're going to calculate b, plug them into this equation for a straight line, and then I can give you an x value that you could use for prediction. Based upon the a and b that you calculated, tell me what the value of y would be if x equals 5. That is what you're going to calculate. So let's break down the equation a little bit more and understand what each of the parts of the equation mean. A is the y-intercept. It's the value of y when x equals 0. Now think about the intercept between the x and y axes, the point where they cross. what would be the value of a data point? Right there where the two lines cross, it would be a value of 0, 0. In other words, x equals 0, y equals 0. So if the intersection of the x and y axes is 0, then if you were to simply move up the y-axis, that means that x would always equal 0, and then you have a value for y. At the point where the regression line crosses the y-axis, the x value would still be 0, but the y value would actually have a number associated with it. Let's say it was 3. So the y-intercept could be 0, 3. That gives us a constant. This a value is also going to be called a constant when we see it in SPSS. Now what about that b value? That's the slope. It's the steepness of the regression line. Now you can see that it's created by, the slope is created with a formula, delta y over delta x. That's the change in y over the change in x. One way to think about this would be to think about a staircase. You probably have a staircase in your home. If not, you've seen them in public places. That staircase has a steepness to it. I remember that in my grandma's house, there was a very steep staircase that went up to the attic. That meant that if I were to stand at the base of the stairs and measure the distance from where I was standing to the point up above where I would be entering the attic, it wasn't that far along the floor, along the x-axis, but it went up quite a ways on the y-axis. Now that would be a steep slope. But think about a wheelchair ramp. That would be a very shallow slope. You go quite a ways along the x-axis and you raise only a small amount along the y-axis. So we could have a steep or a shallow slope on a staircase or on a ramp. Same thing with our line. It could have a steepness or a shallowness to the line. The closer that line gets to a flat line or a horizontal line, the less valuable or the less it tells us about the relationship between the x and y variables. So what the slope tells us is the direction and the rate of change in the relationship between x and y. If the slope is going up and right, that would be a positive relationship. If the slope is going down, it would be a negative relationship between x and y. And the steepness of the slope tells us about the rate of change between those two variables. Once we know a and b, we can plug them into our equation for a straight line, y hat equals a plus bx, and then I can give you an x value and you can solve for y. And what you're going to be doing is making a prediction. I'm going to ask you, what do you predict the y value will be if x equals 3? You plug in 3 for an x with the a and b you've already calculated, and you'll tell me what the y predicted value should be.